Howdy ho, neighborinos! Hello and welcome to Grimlight Games! We're going to be continuing our indie game dev journey today. And, yeah, we've done quite a few things in between now and the last time that we streamed. We've pretty much got our inventory system fully set and operational. So the good news is, now that we have that set, we can kind of just like add things as we need to, right? So we can cycle and scroll through all our different weapons. Our sword is working appropriately. Our bow and arrow is working appropriately. Our staff is working appropriately. And then, of course, you can see that one of our new additions, we have enemies that shoot at us, which is super cool, super fun. And we input a bool, so that way, if we want to make an enemy stop moving to shoot at us, that can happen. And then we can also have enemies that continue moving while they're shooting at us. Eventually we're going to add in some iframes to our dash. Right now we've just got invulnerability, so you can see I kind of like slammed into the ghost and I didn't get hurt, but if I just walk into him, boom, I get bumped back. Okay. We don't have a health system yet though, so we can't die. And it looks like I may have... Oh, he fixed himself, I think. No? Oh, jeez. I think I broke his physics. Alright, that's something that we're going to have to deal with in the future. Yeah, he is. We busted up his physics good. I'm not sure what happened there. It's like he's trying to stop to shoot, and it's just not working out for him. But anyways, I digress. What we're going to hopefully get working on today is we're going to create different bullet storm patterns for our enemies to shoot at us. Make it a little bit more challenging than just those single
to give us a
rate
nice clean slate
fires.
And let's head into our shooter class. With that opened up, let's create a couple.
So let's start here.
Serialized fields that we can use. I think the easiest one to set up first is a private float for a bullet move speed. Now your knee-jerk reaction is probably saying, well, the bullet move speed is in the projectile class itself.
There we go.
So right below update projectile range,
Oh, where is it? We need to open our projectile here, because if we're going to be utilizing move speed in here, we got to change something in here.
Copy this whole method. It might.
Let's projectile range. That's you. Yep. Okay.
Not be the fastest way to do it, but let's also update our bullet speed. Move range. So update move speed. It's going to take in a float called move speed, and it's just going to update this move speed variable up top. So this dot move speed equals move speed. That way each individual shooter mono behavior can...
Okay. What are we going to do with this?
So this dot move speed.
You know, I am pleased that I'm getting a little bit better with my Visual Studio Code shorthand. Seems to be helping my workflow quite a bit. You know, just like little things here and there. For example, putting my square brackets first, then typing serialize field before I auto-complete it, finishes that quicker. I've learned how to comment things out much more efficiently. And of course, just replace entire
that way, each individual
classes all at once.
Behavior can have their own bullet move speed attached to it. Then all we need to do after we instantiate a new bullet is go into our bullet projectile class and update its move speed. Now we could do that the normal way by just going into our new bullet and then getting the projectile component, but I'd like to show you a different way to do that. So the way we do that is type if new bullet dot try get component out.
Yeah, I'm just making a mess over here. There we go. Okay. Note we want it inside of our attack function. New bullet. Instantiate. Bullet prefab. I'm totally copying the wrong line. Good job, buddy. Good job. We'll try get component. So this is a new way of doing this that I have not tried before. So let's see how this works.
Now this is kind of a fancy schmancy syntax, but what this out keyword allows us to do is take a method or a function, pass through a parameter, modify that parameter, and then access it outside of the function. It also allows us to return multiple data types. So instead of just having, say, a private bool function that returns a single bool data type, you could just have a private void function that returns as many parameters as you want. For example, you've probably seen them used before in something like a raycast. But since we're getting towards the end of the course, let's start introducing you to some more of that fancy schmancy we're cool programmers intermediate syntax. So once we've got that projectile, then we can just go into the projectile class, update the move speed, and pass through the bullet move speed as a parameter. Very nice. Next up, let's have another serialized field for the amount of bursts that we want to fire. So private int burst count. And I think it makes sense to do another private serialized field for a float called time between bursts. That way we can move this entire logic into a coroutine and just wait at this designated float time in between bursts and fire our projectiles out and burst that way. So let's move it down to a coroutine. Private IE enumerator out and burst that way. So let's move it down to a coroutine. Private IE enumerator, we'll call it shoot routine. We can shift all of this logic down here, following a similar.
So I think we're going to be getting rid of attack
structure to how we've set it up before with an is.
I mean, we're not going to get rid of it. We're going to move all the logic to our new core routine. Yeah. I'm going to move the whole darn thing. So, ready for this? Ooh. There we go. She be moved. Of course, I do want a space here. I'll just clean that up a little bit.
So up top.
Is shooting.
We'll create a private bool called is shooting, initialize it to false, and in attack, check and see if is not shooting.
You know, actually, I need to raise my chair up. I'm kind of getting a little pain right here. So I think I've been hovering my arm. Where's that lever? There we go. Oh. All right. Oh, good. We're still all on camera. That's the only thing I was... Yeah, that feels much better. So, PSA. For those of you who do work at desks for long periods of time, it is important to make sure that you're not up in your neck all day while you're working, because if you're wondering where your tight neck muscles are coming from, that could potentially be one thing that you're running into The other one is making sure that your screen that you are utilizing is straight ahead, so that way you aren't head tilted forward with all the weight of that cranium pulling down on your neck muscles, or head tilted up, shortening the back muscles and whatnot. And then, of course, you don't want to be slunched forward and looking up at the same time, because as you can see now, this really puts a lot of strain on all of the various neck and shoulder muscles. Yeah, so if you didn't know, in my spare time, I'm actually a personal trainer, and I specialize in functional movement and medicine. So yeah, just a little PSA to help you out with those nagging pains. And I don't know, I mean, if those are topics that you guys are interested in, let me know, and I've got no problem occasionally throwing into our streams, our videos where we're working on indie game stuff, or even just gaming in general, talking about postural health and things you can do to kind of work on that and make sure that you have a very long, prosperous gaming or development career ahead of you that won't end up in crippling neck pain. So,
And we can just go ahead and start that coroutine.
All right. Good old if statement. If it's shooting. And what are we going to do with that?
Start coroutine, shoot routine. At the beginning of our shoot routine, let's set is shooting to true, and at the end of the routine, let's set is shooting to false, but not before we yield, return.
Okay, so in our coroutine, we need to be reset to false.
Turn new, wait 4 seconds, add another serialized field that I'll call rest time. So up top, serialized field, private, float, rest.
All right, what do we want to call this?
I'll call rest time.
Yep, that works for me.
So up top, serialized field, private, float, rest time, and I'll just initialize that at 1. This can work nicely in tandem with our cooldown in our enemy AI state machine, just depending on how you want to set up your cooldowns in between the overall attack, in between bursts, and combine them however you'd like. Next up, let's actually get our bursts firing correctly. So for that, we'll use a for loop. Inside of this for loop, we'll start with I equals 0, and if I is
we're missing something. We need this bool set to true. Wow, that's cool. It set up everything just like that. Oh, fantastic.
The burst count, then we'll add time.
I'm actually really excited to start getting into setting up the different burst patterns and whatnot.
5 or 6 lines inside of the for loop.
So we need tab that. There we go. Oh no. I wanted to tab that too. Right? Okay. Nothing broke? Good. Great.
And before we move on in between each loop, let's yield return new, wait 4 seconds, time between bursts. Beautiful. All right, sweet. Let's go back into Unity and give it
Boom. All right. So, we'll see what we got so far.
To try.
All right.
Let's click our ghost, scroll down to the shooter class. I'm going to change my...
Let's leave these two, but we're gonna disable numero trace and numero 4. The reason I want to leave these two, right? So we're gonna have our stop moving ghost, and we're gonna have our move and attack ghost. And now here's all our fun little variables that we can mess around with.
So we can see it. Let's have a burst count.
I don't think we need to put anything else there because our bullet prefab is already there, loaded in. Mess around with some of these.
Time between bursts. Let's do it something real quick.
And then, how about other Mr. Ghost? Your bullet move speed can be lower. We'll give you a big fat shotgun burst. And you're going to do a little bit longer. All right. Fingers crossed. Woohoo! Nice. Look at that.
0.3.
We done did it.
And I don't really think we need much of a rest time, so we'll just set it at 0.5 seconds for now. Let's click play
we done did
and
it.
Give it a shot. All right, as soon as we get within range, perfect. We've got our ghost firing towards our player. Everything seems to be working as intended so far, and it's already looking pretty good. In the next lecture, let's set up it firing not only in bursts, but what if we want each burst to fire numerous bullets all at the same time? When you're ready for the next lecture, I will see you there.
Okay. So, our next challenge, because we have it successfully bursting. But now, we want to start building towards patterns, etc. So, next we're going to build it so that way all of the bullets kind of burst out at once. And yeah, that's it.
Hello and welcome back. Let's not only get our projectiles firing out in bursts, let's also set it up so that we can change the angle of influence in the inspector to dedicate not only the angle on which the projectiles come out, but how many projectiles come out in each burst. Let's get that set up. All right, so at the top of our shooter class, we're also going to need a serialized field for another private int that I'm going to call projectiles per burst. Let's also create another serialized field that's going to be a private float. We're going to call it the angle spread, but we have to make sure that in the inspector, you can only set the range in between 0 and 359, just 1 degree short of a full circle.
But we need something extra. Range between 0, 359. So I guess we won't do a full 360, which is a circle. If you were
the
wondering.
last one we'll need for now is one more private float that I'm going to call starting distance. And that's going to be the distance that the bullet spawns away from the transform that the shooter class is attached to. And it does have to be a number greater than 0, so for now I'll just initialize it as 0.1f. Below here, let's set up some trigonometry math using sine and cosine to get our angle populating correctly.
Oh, here we go.
So we're going to need quite a few
bust out our trig.
Hold on with me. It's going to look complicated up front, but I think
I haven't done
break
trig
it down
in
line by line, it starts to simplify itself.
A
Need a lot of different floats.
very long time. So we're gonna be moving pretty slow through this. Oh man.
One by one. Let's start with a target angle, and that's going to be mathf.tan2, which, looking right here, returns the angle in radians, whose tangent is y divided by x. It's the same as tan2 that we used for the sword rotation early on. And we're going to use this vector2 target direction of where our player is to find our target angle. So let's actually just promote that up a few lines, and then
Okay. Interesting. So we're gonna move this. But why?
inside a tan2, we can use target direction dot.
Oh, because we need to get this calculation before we... Yep. Okay, nope, that makes sense. Yep. Makes perfect sense.
Y divided by target direction dot x. And then we're going to times it by mathf.rad2 to get it back into degrees. Before we move on, let's look at a nice by mathf.rad2 to get it back in.
Interesting. Okay, this is cool. This is really cool. So what we're really diving into and learning right now is how we can utilize these different math functions. Oh, I was hoping if I hovered over this it would tell me. Oh, there we go. We can just do it this way. Right? Oh, wow. Cool. Very cool.
Into degrees.
All right, so now we've got
on,
a challenge.
Let's look at a nice diagram slideshow that can help us compartmentalize what we're really trying to accomplish. We're about to introduce a handful of float properties, and it can be a little bit confusing as I type them out going from top to bottom. So let's first explain what we're really trying to accomplish with each individual.
Oh, never mind. This
First
isn't
of
a
all,
challenge.
we have our shooter as defined by our ghost currently. Well, we have our...
Okay, actually, I think I want to show this screen just because it'll help kind of explain what it is we're trying to do. So why don't we do that? All right, so let's check this out. We're going to back it up just a little bit.
Shooter as defined by our ghost currently. Well, we have our target direction, and we just defined our target angle. But here's where we start to introduce the angle spread that we defined as a property up top that can be manually set in the inspector. Now, to spawn projectiles within this cone, we'll also want to keep track of the start angle and the end angle. But to calculate these 2 points, well, we're also going to need to know the half angle spread. This makes life just a bit easier because the start and end points are just plus or minus the same number of degrees from the center target angle. From here, we can then evenly distribute the number of projectiles in our burst between the start and end points. And to do that, we'll need to calculate the angle step in between each projectile fired shot. All right, with that explanation, let's head back into our shooter class and define some of those floats. We're also going to need a float.
All right, cool. So, just to help give you an idea, you know, what we're tackling right now, what we're trying to accomplish. That was a pretty good explanation. I liked that.
For the start angle that we'll initialize as the target angle, as well as an end angle and a current angle. So I'm just going to duplicate.
Start angle equals target angle. Fantastic. Now we're going to do that, and that. But we're going to be editing those other two.
We'll need an end angle and a current angle. We're going to need another float called half angle spread that we'll just set to 0 for now, and one more float called
a lot of floats. Angle step
that we'll also initialize as 0 to begin with. Now, if the angle spread is not set to 0, then we want to...
Okay. Nope, there we go. All right, so if we do not
Define some
equal
of those properties.
0.
If the angle spread is set to 0 and we just want it to go in a straight line towards the player, then we can completely ignore some of this logic. But if the angle spread
Great.
is not set to 0, we need to start defining that cone of influence defined by our angle properties set up top in the inspector. So our angle step is going to be equal to the angle spread divided by the projectiles per burst minus 1. So just as an example, if our angle spread was set to something like 80 degrees, and each burst has 7 projectiles, well, we then take the float of 80 divided by the amount of projectiles 7 minus 1, giving us 6. So we take the float of 80 divided by 6, and that will give us our angle step. The half angle spread.
All right, hold on. I'm going to need him to explain that again. It's math.
Tiles per burst minus 1. So just as an example, if our angle spread was set to something like 80 degrees, and each burst has 7 projectiles, well, we then take the float of 80 divided by the amount of projectiles 7 minus 1, giving us 6. So we take the float of 80 divided by 6, and that will give us our angle step. The half angle spread is going to be equal to the angle spread divided by...
I get it now. All right. So it's just, I mean, it's math. It's trig. It's math. Oh, man. You know, I was terrible at math growing up. All right, let me rephrase that. That's not completely true. I strongly disliked fractions, percents, and decimals. And I strongly disliked them because I was not good at them. I didn't fully understand and comprehend. And then later in life, when I was an elementary school teacher, by the way, for those of you playing the home game, yes, my first career job out of school was as an elementary school teacher. So, yeah, crazy, right? And because I didn't really know how to do fractions and decimals and percents, well, it made it challenging to teach it. And of course, being an elementary school teacher, I don't get to pick which subjects I teach. I teach them all. So I had to go back and I had to teach myself math so I could then teach these kids this math. And it's so interesting to me being taught something at a young age where you don't really get to decide what it is you're learning versus teaching yourself something either out of necessity or out of curiosity is very, very different. I found that the only reason I didn't like math, or specifically that kind of math, is because it was never really explained to me in a way that I understood it. And as soon as I started teaching myself much later in life, and I really kind of like got a grasp on it and understanding, I mean, it was great. It was fine. I enjoyed it. And now, I mean, in my current job as a personal trainer, right? So I have to quickly calculate percents for figuring out what weight my client or my athlete is going to work with that day. Just quick example, right? So say, okay, we're going to be working with 75% of our estimated 1 rep max. Okay. So right there, like, ooh, what does that mean? Well, that means we take the calculation based off of what we presume the 1 rep max of the client to be, which I have a fun little formula for that I'm not going to go into detail because it's pretty wild. But we get that number. And from that number, we simply plug in 75%. Easiest way to do that? Multiply that number by 0.75. Now we're getting into decimals. Decimals really are just percents when you go below 100. Yeah. So, I use a lot of that in my every day-to-day life now, which it's funny because I can also remember back in the day you'd say things like, "Oh, when am I ever going to need this? When am I ever going to use this?" And suddenly you're using it. And I'm sure I thought the exact same thing about trigonometry. I was like, this isn't useful for me. I'm going to be an English teacher. That's what I'm going to do. And now here I am doing trigonometry. to make my game. So, yeah. Sorry for that tangent, but hopefully it was entertaining.
By 2,
gave you a little bit.
Is going to be equal to the target.
But let's get back to work. Back to our trig.
Spread. And if we remember our diagram, the target angle is that direct line towards the target. If we add or subtract half of the angle spread, well, then we're going to get one of those two endpoints on either side of the cone.
Okay. So, walking through what we've done here so far. We're first figuring out what our angle step is. And if you recall, right, as we were looking at that diagram, those are the points between our end angle and our beginning angle. So now we figure out what the half angle spread is, right? Like, what is the midline, the middle point between the two edges of the angle? Boom. Now we have to figure out what the start angle is, utilizing what our target angle is, minus that halfway point we were just talking about. So then we can make sure that our bullets are evenly distributed between the two points.
Is equal to the target angle plus the half angle spread. And lastly, the current angle is equal to the start angle. And that way this current angle is going to start out at the starting angle, which defines the first bullet of the first burst. And then we can use these angle steps, the half angle step, and our end angle to find the proper amount that we want to shift our bullet, each individual instantiated bullet. I think that'll make a bit more sense when you see it in practice. We can now start to use a lot of these properties to instantiate our bullet at a specific XY vector 2 away from our transform.
Okay.
So let's actually do that in its own separate function. Down below, let's find that vector 2 on where we want to.
All right. I'll clean this up a little bit as we go. That's something that I want to get more in the habit of, is occasionally just kind of cleaning up my code a bit. For readability purposes, for my own purposes, you know. Like you do.
To spawn each individual bullet. We'll call it find bullet spawn pause or position.
Find bullet spawn position.
We're going to want to create a
Fantastic.
vector 2 that I'm going to call pause, and it's going to be a new vector 2 that's going to take in the x and y floats that we're about to determine. Because we're returning a vector 2, we'll return that pause. Up here, let's define those x and y values. So we're going to need a float x and a float y. Float x is going to be equal to the transform.position of our...
Okay, but we are also going to need to figure those out, right? What does our float x equal? Our float x equals transform.position.
Ghost plus the starting distance for how far away we want to start our bullet away from its transform, times the complicated part mathf dot cosine of our current angle times mathf dot degrees to radians. I'll leave some Unity documentation links.
Oh, good. So he's going to provide us with some links that should help us digest this math a little bit more. And I mean, I'm going to need to dive into that, because I do want to understand what it is that I'm doing. I mean, that's the ultimate goal, right? It's not just copy paste. I want to learn. I want to be able to just say, okay, I want to make a bullet spread angle for this script, and here's how I do it. You know, rather than having to go reference a video and be like, hey, show me how to do this. But we all start somewhere.
In the resources below if you need to refresh yourself on cosine and sine properties, as I often have to as well. For y, we're going to use sine. So transform.
What is broken? $66.30. Oh, so we've got the y there, but we haven't denoted what it is yet. Okay, that's why it's broken. Which, yeah, makes sense. Is this going to be transform dot position dot y? I mean, I'm guessing. I shouldn't guess.
Dot position dot y plus
I was right,
starting distance plus starting distance times mathf dot not cosine but sine. And it's also going to take in the current angle times mathf dot degrees to radians. All right, looking good. We're going to then use those x and y floats, plug them into a brand new vector 2, and then return that position using this friendly
and it's no longer
trigonometry
broken
function. Let's copy this find bullet spawn.
Shoot. I meant to do this.
Position. And right above where we want to instantiate.
Right here. Merp.
Instantiate a new bullet. Let's create a new vector 2 that I'm going to call pos, and it's going to be equal to that function that we just created, which was find bullet spawn position, and it takes in the current angle float that we defined up here. Now, instead of instantiating at our transform.position, let's instantiate each individual bullet at this vector 2 position. So bullet prefab instantiated at...
Oh, okay. Easy peasy.
At pos with quaternion dot identity. Now, instead of the bullet dot right transform equaling the target direction, we want each individual new bullet dot transform dot right to be equal to the new bullet dot transform dot position minus the transform dot position. So because our new bullet is going to spawn just a little bit away from the shooter transform that this class is attached to, we can subtract the transform dot position of the shooter model behavior itself, and it's going to give us that correct direction that the bullet is headed towards. After we instantiate each individual bullet, we want to add to our current angle, adding the current angle to itself plus the angle step. And that will give us each individual step in between each individual bullet on our cone of influence. We need to put another nested for loop inside of this for loop that already exists, since we need to fire so many bullets per burst. So right up here, I'm just going to give us some space and create another for loop, except instead of using I
just got really tired.
We'll just use the common syntax of J. We'll start J at 0, and if J is less than the projectiles per burst, we'll add to J.
There we go.
And then we can throw all of this logic going down to our current angle step and just shift it up into that nested for loop.
Really? All of that, huh? Okay. That looks right. I think so. Okay. Yep.
In between each burst, however, we need to set our current angle back to the starting angle. All right, let's head back into Unity and give it a try. Let's
Okay, we just wrote a ton of code and used a whole bunch of math that we don't necessarily entirely understand. So we're going to see how this works. Nope, that's not what I meant to do. I meant to close that, just that way we don't have as many things going on in the background. We're going to go ahead and disable you for now. So that way we're just going to work with this one guy. We're going to uncheck that.
Let's go ahead and click our ghost, scroll down to our shooter class, and we're going to need to update this projectiles per burst to be a non-zero number. I'm just going to do 6.
All right. So now we get to play around with all this and see how it
angle
works.
spread to
Let's do 120.
something wide, but not too wide, just so we can really see what's going on. I'm going to have my starting distance be at 0.1. That's fine. It'll just be instantiated basically on the ghost itself. Let's go ahead and hit.
Okay. Ready? Whoa. Hey, look at that. Pew, 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 pew. Nice. Wow. Now, just for GPs. Look at that. And I mean, if we wanted to, we can even get them firing in a full circle. Well, almost a full circle, right? It's 1 degree off, and I think the reason for that is because if we hit true 360, it'll end up coming out like 180. All right, all of our bullet clones are disappearing correctly. Perfect. All right. I mean, everything seems to be working just fine. Real quick, let's set him to not move, and we'll see if that works appropriately. Okay, he stopped moving. Perfect.
Hit play and see if we've broken anything.
Absolutely
All right, yeah.
golden.
Hey, that looks pretty good already. You can see once we enter the attacking range of our ghost, it does indeed fire each individual burst properly, angled towards the player. But I'm going to show you one little thing that I'd like to adjust. Let's ramp this up to something a little bit ridiculous, like projectiles per burst up to 20, and shrink the angle spread just a little bit, with the time in between bursts of being something like 1.5, so significantly longer. When I click play, and we enter
I'm sorry.
an attacking range, okay, that was
Something's wrong with my chair. I gotta fix this real quick. Okay, so I just learned something new about my chair, which I've had for almost an entire year now. That little doohickey handle, you know, the one that makes your chair go brrrp and brrrp. Apparently, there's another setting on mine where I can push it in to the chair and it locks it so I cannot tilt back. But if we pull it out a little bit, we can tilt. Simple strokes for simple minds. But I do actually need to take just one more second. There we go. All right. Okay. Now, brain, where are we?
But the point that I'm trying to make is you can see that the burst angle of our cone of influence, even though my player has moved all the way down here, was still pointing to the left. So just to show you that again, it's pointing down, I'm moving over here to the left, and throughout all 5 bursts, it's still going directly.
Oh, okay. So we're gonna have to adjust this next, but let me show ya. So we can see, right? It's kind of in this lower quadrant. Now it's to the right. But now it should be in the exact same... No. No, this is adjusting. What?
South. I'd like it so that in between each burst, we redefine where the player is so that each individual burst shoots towards the player. And it might be easier than you'd think. Let's head back.
Oh, okay. All right, so what he's talking about and what we're going to adjust is, you can see, right? Just the burst happens like that. He's talking about adjusting it so that way if we're moving, the bursts will follow. Like, they won't just come out in that straight line. Now, that being said, I mean, maybe that's the way we want it to play. But if we don't, for different patterns or for a more difficult enemy to dodge, we can situate that.
So in between each burst, we're going to have to redefine all of these variables. So I think the best way to do that is if we highlight all the way from my line 41 all the way up to line 27, the top top of our target direction and the bottom of redefining our current angle to our start angle. With all of this highlighted, you can hover over to this little...
Oh, we're about to learn something new. Okay, hold up. So we're going to highlight all this.
light bulb, or press Control+ for the hotkey and just click Extract.
Huh. Extract method. What?
Extract method. That's going to automatically put this whole method down here that it's named new method.
Oh. Oh, wow. And then new method. And then this is the method. Huh. So now we can call this anytime we need. Oh, that is so cool.
Now we can call this function whenever we want to redefine all of these variables, and it's automatically for us given the parameters that we needed as out parameters that we can use inside of our shoot routine. So I'm going to go ahead, press new method, press Control D just to highlight both new methods, and I'm going to call it target cone of influence. I think I spelled that right. So we're not only going to get our target cone of influence right at the beginning of our shoot routine, but I'm going to copy this entire line, including the parameters. I'd also like to call it at the...
Why? I thought I did that correctly. Hold on. We're going to redo it just because... No. Okay. Not sure why it worked that time, but not the other time. But we're still learning our shorthand.
Shoot routine, but I'm going to copy this entire line, including the parameters. I'd also cone of influence right at the beginning of our shoot routine, but I'm going to copy this entire line, including the parameters. I'd also like to call it at the end of each burst. So right below yield return new weight for seconds, time
Oops. There we go. Oops. Man, I was screwing some stuff up there.
Time between bursts. I'm going to redefine where my player is so that each individual burst is targeted towards the player. Let's head back into Unity and see if that's working as intended. All right,
I feel like, though, we might want to set this up as a bool. We'll see. Let's see how it works. Okay, yeah.
I'm going to click my ghost. I think my angle arc was a bit too ridiculous. I'm still just going to shrink that down quite a bit to something really small. Change my projectiles per burst to 10, not too important. All right, in attack range, and yes, it looks like it in between each individual burst, it is aiming towards the player. All right, we are set to go. And this is already starting to get really powerful. You could have a plethora of different enemies that all use this shooter class in different ways. Now, we're not done yet, but I'd like to show you just how fun this can be. I'm going to increase my angle spread all the way up to a full circle, increase my projectiles per burst to something ridiculous like, I don't know, 40. We're going to make that burst count also something really high. 8, bullet move speed is 12. I'm really just throwing in random numbers just to kind of give you an idea of how customizable this is. We'll keep the starting distance the same and the time between bursts, let's do it nice quick succession, something like 0.3. Let's blow up our game view for cinematic effect, hit play, and watch it all come together. Yeah. Oh, baby. That is looking good. The endless options that we have with our shooter class are going to keep me busy for a long, long time. Well done on this lecture. We're making some great progress.
Okay.
I've got just a few more things I'd like to include in our shooter class before we move on and wrap up our shooter class entirely.
I'm
When
liking
you're
it.
ready to head into the next one,
I'm liking it a
I'll
lot.
see you there.
So it looks like we're going to be working on oscillation and stagger next. But we are approaching our hour mark. So, yeah, let's take a little break here. We are unfortunately going to have to end this stream early. Not now, not right this second, but my first afternoon appointment is a little bit earlier today than it has been. A client who was gone for an extended period of time has come back, so unfortunately that does mean moving forward our Wednesday streams are not going to be as long as we've been accustomed to. But that's okay. We'll be fine. We'll survive.
Hello and welcome back. In this lecture, I'd like to add a little bit more depth to our shooter class, adding both oscillate and stagger properties. Let's get that set up. Let's start by adding those.
Okay. I'm going to add in some oscillation and some stagger.
Two serialized fields as bools that we can modify in the inspector.
Perfect.
So
Here's
one,
where we can
bool,
start to
I'm
add
gonna
in
call
some
it
bools.
stagger, and I'll have a second one called oscillate. With stagger, we can get each individual bullet in our burst firing one at a time, and oscillating, we can get it to oscillate or ping pong back and forth in between each burst. Let's handle staggering first, since I think it's a little bit easier to wrap our head around with what we currently have set up. Below our start, current, and angle step, let's create a new float that we can define.
Our enumerator is shooting a float.
As our time between, not bursts, but projectiles. And we'll just start that defined as 0. Below our target cone of influence, let's go ahead and say if stagger is enabled, then we want to make time between projectiles equal to time between bursts divided by projectiles per burst. You could divide this in between a couple different lines.
Okay. So this actually seems like it's going to be fairly easy to situate. Tiles. I should have done this. Oh well. Equals time between bursts divided by projectiles per burst. Okay. It's a little messy. We'll clean that up though.
As such, but I'm just going to keep it all in one line. I think it looks a little more clean in this context. So if we're staggering,
yeah. I mean, you're not wrong. What do you think, guys? Does this look better than how we had it? I mean, as we're just situating the stagger bool, I kind of do like that for readability. Yeah, I think I do. We're going to go with that.
we can use this float time between projectiles and just check down here at the bottom of each individual instantiated bullet. So right after we increase our current angle by our current angle step, we can just say if stagger, then yield return new, wait for seconds, and then pass in our time between projectiles float that we defined.
Okay. Wait for seconds. Time between projectiles. We do have to remember that that is a very different
Find up top
thing.
All right, with the stagger rigged up, let's go try that out. And
Okay. Now we're going to see if stagger works.
Unity and see what it looks like. I'm going to go ahead and just change a few properties on my shooter class. Let's keep the bullet move speed at 5. Let's change the burst count just to 3 and projectiles per burst. Let's change it to something like 8, and then I'm going to drastically reduce my angle spread.
Let's try a 90-degree angle. Sometimes I forget. You can just put the number in.
Distance of something just a little bit bigger. Around 0.3 might look a little bit more clean. Time between bursts, let's make it 1 just to make everything nice and crystal clear. And the rest time is not all too important for now. Let's enable our stagger property, give it a play, and we'll see what it looks like. I've got each individual.
You ready, guys? Here we go. Hey, look at you staggering that angle. Oh, that's kind of cool. Whoa. Now let's see if we can fire under duress. Woohoo! Oh, that's right, because these are all like within the burst. So we trigger him, right? Now he's actually going to keep firing because he's got what? 5 bursts. But each burst is going to continue to be targeted towards us. Interesting. Okay, we're going to have to keep that in mind for enemy design. Because now he doesn't know where we are, right? So he's not shooting, but we get close, and then boom. All of a sudden, now we're going to get that 5 burst again. But he's dead. He can't do anything.
Bullet coming out one at a time in a nice spray and pray sort of pattern. I think that looks really good. Now this is in no way that important, but I've got my bullet just a little bit too white. I think it conflicts with some of our other white glowy materials. I think I'd like it to be sort of an off purplish pink color. So with the bullet sprite renderer still just that little bit of an offset blue, I'm just going to increase my red just a tad, just to kind of give it that nice purplish pinkish tint. I think that looks a little bit more defined on our green grass. All right, back into our shooter class and let's set up Oscillate. Now this one can be a tad more tricky to wrap our head around, but what I'm going to do is I'm going to take this target cone of influence that we're redefining at the end of our loop. I'm just going to cut it out and plop it.
So why are we cutting it?
To the top of our eye loop.
Okay.
And we're going to check and redefine our target cone of influence if we're not oscillating. So I'll go ahead and just wrap it up.
Oh, okay.
Such.
That's
So if
why
it is
we moved it.
oscillating, then I'd like to redefine a couple of my properties. I want to
I
change my
understand
current angle
the
equal
logic.
to my end angle to get that back and forth motion. Now in our target cone of influence, we weren't outputting our end angle float. So let's go ahead and set up
Okay, we gotta put that out, huh?
our target cone of influence function to do that. So out, end, angle.
But is that gonna affect the rest of them? Okay. Maybe we only need it for this one, so it doesn't
Down
matter.
here in our target cone of influence, well, all we need to do is also
Oh. We've got to set it up to step that out. Gotcha.
our end angle. And instead of defining it from scratch, we can just go ahead and delete that float wording. Make sure that we don't just put out, we put out float. And we're set to
Okay.
go there. Now,
Oh, so we don't need that anymore. Okay. Didn't I just fix that? No? Oh. Commas are very, very, very important. Do you want to know why commas are important? Because a comma is the difference between helping your Uncle Jack off a horse and helping your Uncle Jack. You can put the rest together on your own.
now we have our target cone of influence function.
So yeah, commas are
outputting
important.
our
But this is something still broken. Something's still broken. Out, angle, step. Out, end, angle. Out, float, end, angle. We haven't spelt anything
end
wrong.
angle float as well, so we can use it up top. So now we just have to make sure both this target cone of influence and this function up top are both outputting our out.
Oh, that's it? Why didn't we just do that to start? I mean, I guess that did not change it.
Out, end, angle. By our start current.
Oh, so we still have to situate it here. Gotcha. And now it's not broken.
And angle step, we also just need to make sure we're defining our end angle up top here as well,
Okay.
and it'll get rid of all those compilation.
Makes sense.
Great. Now back down here, when we set our current angle to our end angle,
We're at oscillate, current angle, end angle.
it's oscillating. Then we also want to set our end angle back to our start angle back to our current angle, And our angle step, we'd like to reverse
Jesus.
it. So we just need to times it by -1 to get it oscillating back in the other direction. Let's go try that out back in.
Hold up. I think I understood everything he just said, but I want to try and walk through it with my own head. Okay. So, if we're not oscillating, then we'll just do the stagger, right? Because if stagger. If we are, in fact, oscillating, the current angle will shift to being the end angle. The end angle will then become the start angle, and the start angle will then become the current angle, and the angle step is going to multiply itself by -1. So, in theory, that should reverse the burst, right? So it's going to burst in one direction first, and then it should switch because we've just multiplied the angle step by -1, and then the next burst should switch back because it's going to multiply itself by -1. Okay, I'm 35% sure I completely understand what's happening here. Oh, I was like, why didn't that? Yeah, because we didn't save it. Don't be such a dingus.
Down here on our shooter class, let's enable this oscillate property.
Okay. So we've got our ghost. We want it to oscillate.
I'm going to go ahead and blow up my...
And I think you also want stagger on when it's oscillating. Well, let's see. Let's see what it does, right? Some experimenting. Look at us oscillating. So, I'm going to assume stagger is necessary. Because let's see what happens when we turn it off. We have oscillation. Yeah, because you can't oscillate without the stagger, right? So that makes sense. So anytime we want to oscillate, stagger must also be on. I wonder if there's a way we can make it a dependency. So that way, if we turn oscillate on, stagger gets set to true, just so that way it...
My game view, just so we can see it a little bit more crystal clear. All right, we've got it firing one direction, and yes, we've got it firing back in the other direction. You can see that it's going...
Yeah, so we can make a redundancy check here, right? So we can just set it to stagger equals true. All right? So let's test this redundancy feature out. I mean, is it necessary? I don't know. Because in theory, right, we can just set stagger to off, but oscillate is in fact on. So in theory, when we hit play, it should turn stagger on. It did not turn stagger on. Wait, yes it did. Interesting. Okay, so the first one, I guess it didn't have time to turn it on. So in the order of operations, we would need stagger to be first. Interesting. Well, here, let's try something. What if we're further, like we're outside of his shooting range? Let's see if stagger turns on. Okay, so he has not shot at us. Stagger has not turned on. So the first one's going to come at us like, yup, and now stagger's turned on. Okay, which means the next one is going to stagger and oscillate. So, I mean, I guess in theory, that doesn't matter. We'll just take that out completely. So what we would need... We would need it here, the check here, to start prior to that. So, just because we're testing, right? Do we just want to do a separate if statement inside of it? I guess we probably can, right? If stagger. Or no. We want if oscillate, then stagger. So if oscillate equals true, stagger equals true. That should be a pretty simple, easy redundancy check. All right, so we're outside of his range. Oscillate is selected. Now, as soon as we move within range, it should check and fire. Look at that. Okay. So if we intend on oscillate, it will automatically do that. Now, if we turn oscillate off, it should stagger. And not oscillate. Yep, so it's just going to keep staggering like that. Great. And if we turn that off, then it'll burst like regular. Turn oscillate on. Stagger comes on. Perfect. Okay, that's easy. Easy redundancy check that takes care of that. So if we intend it to oscillate, it will oscillate, even if we accidentally don't turn stagger on.
Oscillating in between each burst. Now I'm just going to try something. Let's put our burst count something a little bit higher. 8 projectiles per burst is fine. And our time between bursts, we'll keep that at 1. All right, perfect. We've got it oscillating back and forth, but we have a similar issue to what we had before. It's firing each individual burst from this top right to bottom left sort of direction because that's where our player originally was when we defined our cone of influence. So if I walk all the way over here to the bottom right, we've got the same.
Oh, okay. So we're just going to test that real quick. So this is what he's kind of talking about. So our cone of influence is being determined, right? And it'll follow us within the cone, but if we move up here, he's going to continue shooting down here, and that's just, well, he's not going to hit us because he's a big dummy. Okay.
Same issue.
So we're going to adjust for that now.
Issue if we're not oscillating, but if we're oscillating, I'd like it to still be pointing towards the player. So the way that I'm going to handle that is with a modulus operator. So down here, when we check if it's not oscillating, well, that looks good. I'm just going to go ahead and close that off. And right below here, let's also check that if oscillating and using the modulus operator, if I modulus 2.
Okay. So we want to actually put something between this and the else. And this is another functionality that I've not used before, so this is new to me. I % 2.
2 is not equal to 1. Then let's redefine our target cone of influence. Now, just as a reminder, this modulus operator is going to check and say, hey, if we take I and divide it by 2, does it have a remainder of 1? And if it doesn't, then go ahead and redefine our target cone of influence.
Okay.
So instead of just else, let's go ahead and say else if.
Oh my. These are two separate if statements. We do need to be aware of that. Else if.
just to make sure it's still oscillating. And then we can throw in all this oscillating redefining logic here. Get rid of that.
I'm sorry, what?
All this oscillating redefining logic here. If, just to make sure it's still...
Sorry about that. Okay, so if oscillate.
Oscillating. And then we can throw in all this oscillating redefining logic here.
Okay.
Get rid of that.
And then we don't need that else? Huh. Easy squeezy, lemon peasy.
And I think we look pretty good. All right, let's go ahead and...
Okay. Now we see if it works. And I mean, we can leave our redundancy check in. In fact, I think we should. But now, in theory, if he starts shooting, it should continue. The cone of influence should change as we move. So he's now oscillating. Yup, it is changing. Ah! Oh no. Okay, so in between bursts, checking where my position is. Cool. Hide behind the tree! All right.
Give that a try. Back in
Hey,
Unity.
we're-
All right, let's approach our
We're
ghost.
doing pretty good
We've got
here.
one
Everything
burst,
is
it's oscillating
functioning
back and forth
as
to the other direction.
is
And that wasn't a
intended.
very good example, but if I come back over here, we're still in the same burst cycle, and we're now pointing towards the player every other oscillation. And hey, you know what? I think that looks pretty good. Just to try something fun, I'm going to go ahead and up my bullet speed, burst count, something ridiculous like 12, and projectile bursts, also something ridiculous, maybe something like 14. Increase my angle spread just a tad, and my time between bursts, something like 1. Let's go ahead and click play and just kind of see what that looks like. Cool, we've got it oscillating back and forth.
Pardon me. We're gonna finish
One more
up
thing
this.
that I'd like to change is I'd kind of like this ghost to have somewhat of a spray and pray sort of model.
This
I don't really want there
modular.
to be a wait time in between each individual burst. I'd kind of like it to just continually oscillate back and forth. Well, luckily, that's just one simple fix. Let's go ahead and back in our shooter script, where we're waiting in between time bursts. I'm just going to...
Okay. We're gonna add in something. Where is? Excuse me. Current angle, start angle. We're gonna add in something. What are we adding in?
say only use that yield if we're not staggering. So I'm going to set it up just like this.
Interesting. If... Oh, so this is why the redundancy check is we don't want it. Okay. So I'm going to remove it, but you'll understand why I'm going to remove it in a second. I probably, yeah, I mean, hindsight, right? I should have waited to see.
Going to go ahead and cut that out. And now...
Gotcha. What? What? The heck happened there? That was weird. Anyways.
Now, we should only wait in between time bursts if we're not staggering. Let's try this line out back in Unity. All right, yeah, you know what we've got?
So this is, yeah. What this allows us to do is now we take out our redundancy check, right? Because we now have two different things that our enemy can do based on whether or not those are selected. Okay? So, no stagger, oscillate. It should be a continuous spray. I did something wrong. What did I do wrong? What did I do wrong?
We're not staggering. Let's try this line out back in Unity. All right, yeah, you know what? We've got it oscillating back and forth in a bit of a spray and pray. And every other burst, we redefine where our player is.
Well, hopefully we can debug this before it's time to go. Why? You are no longer oscillating. Mm-hmm. Hmm. Oh. That's why. How did that happen? Well, I must have screwed something up, or maybe I don't know. Let's see. So we've got oscillate and stagger on, so it should go. Okay, yep. Wait, no, that should be if stagger isn't on? So what if we turn stagger off? What happens then? But no, that's not what I wanted. I wanted it to be able to... Well, alright, so maybe it can still kind of work the way I want it to, but we've got to change it to something like this. No? If we turn time between bursts to 0. I mean, that just completely stops it from doing it. If we turn rest time to 0. No. Well... That's a bit of a sticky pickle, huh? Unfortunately, we don't have enough time to really dive into that and see if we can, in fact, set it up so we can have it the other way. Right? Because... No, something's still screwed up. If we don't have stagger on, it should still oscillate. I mean, this is correct. So if we have oscillate on, do this, do this. Would we not? Alright, we're going to try something real quick. I'm going to ask my assistant to give me a hand here. I've got a challenge. I want my enemy shooter to oscillate wait, I need to remember, what does it do? Okay, so if these are both selected, or maybe, okay, so stagger, oscillate, they're both sort of, maybe because I didn't have time between bursts set. Oh. No, because it's just one. We need to change that. Okay. Maybe it does work and I'm just an idiot. No, that's just oscillating without staggering. But if we turn stagger off, then it just bursts out. There is no oscillation. Turn stagger on without oscillate. What? That's interesting. Currently written. With just stagger enabled. Alright, what does it do with just stagger? It just goes left to right in the cone pattern. Okay. Now if we enable both of them, it does the continuous back and forth spray. With just oscillate enabled, and then with neither selected, all right. We're just going to see what we come up with for some debugging here. But unfortunately, we're not going to have time to really dive into this. I gotta get off now. But let's see first what we're potentially running into. Okay, so the changes. Smoothly oscillate between angles without any pauses. Continuous spray of projectiles. Oscillate plus stagger. Projectiles oscillate in one direction, pause briefly, and then reverse. Includes a staggered delay for each projectile and a pause before reversing. Default behavior. No oscillate, no stagger. But what about stagger only? Well, let's... What does it do right now with stagger only? I mean, with stagger only, right? It should just... Yeah. So maybe that will continue to do what it's supposed to? Alright, we're just going to try this real quick. That's the wrong one. This is the one we want. Newer shoot routine. Okay. We're going to just go ahead and boop. That completely broke. Why did that completely break? Oh, because it's just the shoot routine. Gotcha. Herpader. Okay. Again, we're trying to do this in the limited amount of time we have. I just want to see else. Shoot, that should be just where it opens. Is shooting equals false. Okay, so it's here. Oh my god. Oh my god. Why are you making this so hard? Okay. I just want to see if this works, and then we'll look at it later. Yeah, I'm so far out of time. Jeez almighty. Alright, okay. We have stagger, oscillate enabled. So with stagger, oscillate enabled, interesting. Very interesting. Okay, so let's try just stagger. What? Oh man. That's not a stagger at all. What did we do? How about oscillate without stagger? That... Oh man. That's... Nope. 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 Okay. Alright, we're gonna have to mess with this another time. Hey, thank you so much for joining me today, guys. I had a blast racking my head with this problem. Obviously, there's still some kinks we need to work out, as it's not doing exactly what we intend it to do. But yeah, we're gonna get that all taken care of at some point. But yeah, thanks so much, guys. I will catch you in the next